Hello world, my name is Victor Engelmann, and in this video I'm going to show you the QEMU virtual machine. There are different virtual machines out there like VirtualBox or VMware or Microsoft Hyper-V. And QEMU is a very popular virtual machine in the Linux world, especially between kernel developers, because it has some features that are really very useful to kernel developers. But I don't want to talk about that topic very much in this video. Here I really just want to give you an overview over how to use QEMU. So what is a virtual machine? It's a software that emulates hardware. So you run a program, and then that program behaves as if you had a separate computer. Okay, and to do that, you basically need to describe how the computer should look to the software, and that's just the typical stuff that you would do with an actual computer. Also, you need to define how much RAM do you want to give it, how many CPUs do you want to allocate for it. You can give a virtual hard disk to it. You can use CD images and use them as virtual CDs. And let's just dive right in here. I've prepared this directory here, and in here you see this file core plus current.iso. That's a CD image from the TinyCore Linux distribution. Almost all Linux distributions will give you some kind of a CD image, DVD image, whatever, in this ISO format. And you could burn that to a CD and boot from that CD. But as I told you, you can also take just such an image and use it as a virtual CD for your virtual computer. So what you could do is you could say QEMU system x86-64. So this will emulate a 64-bit x86 computer. Okay, and if I just launch it without anything, then it tries to boot, but there's just no boot medium. So it cannot boot. This is what it tells us here: no bootable device. But actually, if I had some PXE boot enabled device on my network, which I don't, but if I had, then I could boot from that without further parameters here. But okay, so I cannot boot anything. I have to give it some boot medium. And if I want to use this TinyCore image here, I can do that by specifying -CD-ROM space core plus current ISO. But I think if I only did it this way, it wouldn't try to boot from it. I have to also tell it to use this as the boot device by also using the parameter boot. And now I have to tell it what to use as boot device. And this is a bit stupid. I don't like this very much, but the notation here is taken from the Windows drive letters. So if you would say C, it would boot from a hard disk. If you say D, it boots from a CD. It's like in a machine that only has one hard drive and one CD-ROM, Windows would give the drive letter D to the CD-ROM. Okay, so that's why you have this. And let's just boot TinyCore here. This takes a while. Okay, so QEMU has now booted TinyCore, As you can see, there is a mouse cursor inside this window, and I have a separate mouse cursor outside of the window. And yeah, if I click into this window now, then QEMU steals my my mouse, and now my mouse cannot exit this window anymore. Okay, but yeah, that's you don't need to panic. You know, in the title bar, you can see it tells you to press Ctrl-Alt-G to release the mouse, and yeah, now I have my mouse back. But yeah, now I have a running tiny core system here. I can start a terminal in here. Okay, and yeah, okay. This is how you can boot from a CD. Okay. Booting like this has a bit of a disadvantage, because so if you'd work on a Linux distribution or a Linux kernel, whatever, this would have the disadvantage that yeah, you might have compiled a kernel, and now you want to try this kernel, and you for that you want to boot the kernel, but yeah, for that you would always have to create new CD images, you know, and pack the kernel and a bootloader and the root drive into that CD, and it would take disk space, and it would just take some time to create that CD image, and that would just be a bit time consuming. And QEMU has a very useful feature. It comes with a built-in bootloader, so you don't need to give it a bootloader so that that bootloader can look at the raw data and decide what to do. You can just tell it, hey, I want you to boot this kernel, and if you notice, I have here this BZ image. This is a kernel that I've created in my video about creating a minimal Linux with just BusyBox. I will put a link in the description for that. So in that video I created this BZ image kernel and this init-rd image. You know, Linux distributions or Linux systems in general require always two things, a kernel and a root disk. And yeah, an init-rd is basically a root disk. So you can say kernel BZ image and init-rd image, and then it can boot that kernel with that image directly without taking a bootloader of some image in between. Okay, so yeah, here okay, Ctrl-Alt-G again and close it. Now, I don't know if you can hear this, but my laptop is getting a bit loud because the CPU fan is spinning. Because yeah, when you run QEMU like this, it uses a lot of system resources, because it really emulates a processor, and emulating a processor requires a lot of resources, because every instruction that it emulates has to run through some software loop, and yeah, that's just a bit inefficient. What you can do instead is you can turn on hardware acceleration for your emulation. And yeah, I mean, all modern computers these days come with a capability for hardware accelerated emulation. You might have to turn it on in your BIOS. So you have to boot your computer and press some dedicated key, like here it's the escape key. But that depends on the manufacturer. So typically you will have some message somewhere on the screen telling you which one it is. And yeah, then you get into your boot menu, and yeah, then you just have to look around. Here it's the BIOS setup, advanced, and I think system options. Here, yeah, virtualization technology, VTX. On AMD processors, this technology is called AMD-V, okay? But yeah, on Intel processors, it's called VTX, and yeah, it's turned on here. So if it wasn't, then you would have to turn it on, and then exit and save the new configuration, save changes, yes. I didn't really make changes, but let's pretend I did. So now that you've activated hardware acceleration for your emulation, you can now start QEMU a bit differently. You can tell it to use CPU host, so it will then use the capabilities of your CPU, of your host CPU. And yeah, the stuff will run directly on the hardware. Okay, but this only works. You know, I'm running x86-64 here. Using the host CPU only works if the machine type you're emulating is the same machine type that you are of your physical machine. Okay. Okay, CPU host and enable KVM. That's another option that you need to pass to actually turn on the hardware acceleration. KVM stands for kernel-based virtual machine, and yeah, that's really the back end for the communication with the hardware. Okay, and now if I would boot it like this, then the virtual machine would only get one processor, but you can also pass it -SMP and a parameter like 2 to tell QEMU to allocate 2 processors to this virtual machine. Okay, and then you can also pass -M to tell it how much RAM you want to allocate for this virtual machine. Let's say I'll give it 2 GB of RAM. Okay, let's launch it like this. You will notice it boots much faster now, and yeah, look how fast it boots. I don't even need to fast forward this. But more than that, it just doesn't use as much system resources. Okay. Now, under certain circumstances, you don't want to boot from the same CD image over and over again, or the same initial RAM disk, because these are fixed things. So if you make any changes, they are not saved anywhere. So if you reboot that machine at some point, all your changes are gone. So so if you want to save your changes, maybe install your the operating system in your virtual machine, then of course you need to create a virtual hard disk, and then you can use that hard disk to store data on that hard disk. And to do that, you can use the tool QEMU-img, create, and give it some file name, let's say hda.img. But we also need to give it a format like qcow2. Well, cow stands for copy on write, I think. So Oh, of course, you need to give it a size. Okay. Now it's created that disk, and we can now run QEMU and give it this disk with the parameter -HDA and then the image file. The naming here is, by the way, that's the old way Linux named its hard disk dev entries, you know. Today Linux names its hard drives SDA because of the SATA attachment. But in the old days, when we still had IDE connectors for our hard drives, Linux named the hard drives HDA, HDB, and so on. So that's where that comes from. And now in here we now have dev SDA. Strangely enough, here it's SD, as you would expect it. And yeah, now you can do the usual stuff like sudo fdisk SDA, create a new partition, primary, partition number 1, first sector default. Let's give it 100 megabytes for the first partition and activate it. You know, in my video series about Linux from scratch, that mistake caused a lot of problems, not activating the first partition. Okay, create another partition, primary, partition number 2, directly behind the first partition by pressing return. And yeah, by pressing return again, I accept the default value, which is to use the entire rest of the hard disk. Okay, write. Okay, and now I could format this like mkfs ext2, let's say. Sudo. Okay. And now I could mount that under MNT, for example. Okay, there's nothing here except this typical lost and found directory. And now I have a foo.txt. And if I would reboot now, and there's our foo.txt. Okay. Now, if you imagine that you are running a huge data center, let's say with really large server systems, and you're running hundreds of virtual machines, you might want to run the same operating system on all of your virtual machines. And you wouldn't want to install it on each virtual machine separately, right? And you would also not want to waste all the hard drive space when you create a separate virtual hard disk for each and every virtual machine that you have. So, and I mean, if you install the same operating system on all of them, then yeah, you would have hundreds of copies of the same files, and yeah, that's just inefficient. So what you can do with QEMU instead is you can create one hard disk, install your operating system on that, and then you can have all your virtual machines use that hard disk. Okay, but I mean, this would of course cause problems with reading and writing. Okay, you wouldn't want one virtual machine to write something to your disk, and this shouldn't disturb something that another operating system does. So what you can do is, and of course, maybe you want to do different things with different copies of that virtual machine, right? So what you can do is, you can take this virtual hard disk and make it a base system. So so that for all your virtual machines, you can then just make a file that describes the differences between its hard drive and your base hard drive. And that's called an overlay. And to do that, you can again use QEMU-img, create, format qcow2, and the name for the file that you want to create, and again a size. But now to specify which hard disk to use as base, you also have to pass -b hda.img and also specify the qcow format for that image. And yeah, this looks good. So now we can boot from with this image instead. And yeah, there you have the foo.txt. Now, one thing I want to mention here is these overlay images, they are delta images. So they only store the difference between your base image and your current image in here. And yeah, this can really be a problem because when you change the base image, like for example, let's say you want to install updates for your operating system, you might try to boot your base image, install the operating system updates, and yeah, then shut it down again, and then use your overlay images again. Yeah, changing the base image invalidates the overlay image. So yeah, that's a problem in reality, but yeah, that's the way it is. Okay, let's talk about networking. You can reach your host machine, you know, your physical machine, under the IP address 10.0.2.2. You know, I can ping it. QEMU just presents this IP address as a virtual IP address inside the world that the virtual machine lives in. So, so for example, you could do something like netcat listen on port 12347, and then in here telnet 10.0.2.2 12347 hello. And yeah, this data has come out of the virtual machine now. yeah, now I've answered into the machine. Okay, so my physical machine has opened a network port, and the virtual machine has now connected to that. Okay, so now we know how to connect to the host machine from your virtual machine, and yeah, you can also connect to any other place outside your machine, like here 8888 is a Google DNS server. It's quite common to ping that to test if you have internet connectivity. And yeah, so from my virtual machine, I can ping that 8888, okay? But what about the other direction? What if I want to connect to the virtual machine from the outside? I mean, when you're running virtual machines, chances are you're trying to run some server software, and yeah, so you would want to have some access to the virtual machine, of course, because the server without access from the outside doesn't do much, right? So let's see. Interface configuration says the IP address is 10.0.2.15. Okay, so now let's run a netcat server here. Netcat listen on port 12347. Okay, so now I've opened a server on port 12347, and yeah, let's try to connect to that. Netcat 10.0.2.15 port 12347, and yeah, it immediately stops. Nothing has happened, and you don't see anything here inside the virtual machine, so yeah, the connection didn't work. Okay, so let's do the next test. Can we even ping this machine? 10.0.2.15. It says the target network is not reachable. Next thing you would do for network troubleshooting would be to trace path, and yeah, you can see now when I tried to connect to this machine 10.0.2.15, it sends the data to the gateway, so to my router, and from that router it is sent to my internet service provider, my ISP. And yeah, that's not something that's gonna make my ISP very happy, because this 10 dot whatever range is specified, officially specified as a private network range, so you are not supposed to send anything out into the internet with 10 dot whatever addresses. And that's why my ISP then correctly terminates any attempt to access 10.0.2.15. And yeah, the thing is, this virtual machine is inside a virtual network inside my actual machine here. So so even the host machine outside doesn't know about this IP range inside that virtual environment. So if I would do something like IP root show, you see I don't even have a root for that IP range. So it absolutely makes sense that my host machine will send out this data into the internet or to the router, and the router doesn't have a root for that IP range also, so it makes sense for the router to send it out to the internet. Because as I said, this network is really isolated, and there's just no way in without something going out first. And yeah, if you want to permit something going into that virtual network, then you can start your QEMU again with the same parameters as before. But you also have to tell it that you want to allow certain packets to go into that virtual network. You can do that with -net space And then the specification of a network rule that says user, comma, host forward equals TCP packets, then colon. Here you could put an IP address to limit who is allowed to send data in there, but I will just not put anything here. So just the next colon to specify the port. I will take a different port here. So data that arrives on my host machine on port 12348 should be forwarded into that virtual machine. Here I could now put the IP address that I want to forward it to, but since QEMU will manage that automatically anyways, I will just put another colon here and then 1, 2, 3, 4, 7. So data that arrives on my host machine on port 12348 will then be passed to the virtual machine on port 12347. Okay, I hope that makes sense. Now, one thing, if I start it like this, I will have a problem. It now says hub 0 with no NICs. So for whatever reason, I really don't understand this, but this network rule has prevented QEMU from adding a network interface controller to the virtual machine. Don't ask me why, I don't understand it. And this syntax here with this net user, comma, host forward, this also changes in the last time. So when you're watching this video, maybe it has changed again. So if all else fails, look it up. So as I said, this virtual machine doesn't have a network interface controller. So to give it one, now I say -net space NIC as an additional parameter. Now I have this network rule and a network interface controller in the virtual machine. So with ifconfig, you see ETH0 means I have a network interface controller with this IP address. So now let's run netcat listen mode port 12347. And I will put this window in the foreground. And let's try again. So netcat. Now at this point I don't have to connect to 10.0.2.15 because the actual port for this server application is now on my host machine. So I can now connect to 127.0.0.1, which is the loopback device. So connecting to that IP address connects you back to yourself. And then 1, 2, 3, 4, 7. No, not 7, because remember, I forwarded port 12348 to 12347, okay? So this running on 12347 inside the virtual machine means that I have to connect to 12348 on the host machine. So 12348. And now I have a connection. So if I say hello, there it has appeared in the virtual machine. And there is my response. The way that we did the networking here is called network address translation for the data that is going out of the virtual machine to somewhere else, and port forwarding for the data that is coming from somewhere else to the virtual machine. And yeah, network address translation and port forwarding, they are easy to configure, and for many applications they are sufficient. But yeah, they have some disadvantages, and doing this in a better way with a bridged network is more complicated, and I think that would be too much for this video. So yeah, I will make another video about that topic, and let this be sufficient for this video. Okay, now imagine that you are running some data center with lots of servers, and a lot of these servers are running virtual machines. Now, if you want to access one of these virtual machines, you wouldn't want to go to the physical server that it's running on and go to its monitor and work on a window on that physical machine. You might not even have access to that. So so another way to access your virtual machines is you can run them with the parameter -vnc and then give it a display number like :0 here. Okay, and now it looks like nothing happens, but yeah, QEMU is now running in the background. It just doesn't show you this window, okay? But the machine is running. And if you want to access this now, you don't need to be physically in front of that machine. You can just go to a different machine and through the network connect to your QEMU with any VNC viewer, like, I don't know, Tiger VNC, or there's a lot of different VNC viewers. And yeah, now you can access this virtual machine through VNC. Okay. Okay, so this is really useful when you want to run your virtual machine maybe with some on a machine that has some physical distance, maybe in some data center in a different city. So so yeah, then you don't need to be physically there to access your virtual machine. You can do that through the network. Okay, but I think if I close this window now, yeah, I can just connect to it again. So so yeah, closing this window now doesn't terminate the QEMU instance. So yeah, I don't know, let's tell it to shut down. And yeah, as you can see now, this program has also exited. Now the last thing I want to talk about is yeah, a GUI program which lets you do all this stuff in a graphical user interface. That's called virt-manager. But yeah, virt-manager prefers to communicate with its QEMU through a daemon called libvirt-d. So sudo system control start libvirt-d. Okay, now that's running. I can check the status. It's complaining a bit about a firewall backend, but anyhow, as you would do it in a systemd environment, you can configure libvirt-d to launch automatically at system startup, but yeah, I'm not gonna do that right now. I'll just start virt-manager. And yeah, this is a typical graphical user interface similar to VirtualBox or Hyper-V or whatever. And so here, through this button, you can create a new virtual machine. I will select to boot it from an ISO file. Browse, browse. I will use the TinyCore image again. Yeah, select just some generic Linux here. To select the memory and the CPU presets. You can change that to your liking anyhow, but these are suggestions based on which operating system you selected. Yeah, let's create a hard drive for the virtual machine also. And yeah, here we are booting TinyCore from this virt-manager. You see it's maybe a bit easier because it tells you more what to do. But yeah, I personally just like doing this stuff on the command line, and I just think that gives you a bit more control. So yeah, anyhow, that's all I wanted to show you today. Again, the networking was a bit primitive so far, but as I said, I will make another video about some more advanced networking in such a virtual environment. And yeah, but for today I think this is enough. So if you like this video, like it, share it, subscribe, and see you next time.